Hello, so in solving this question, determine the equation for the tangent to the curve y equals x ln x that passes through the point 0e. Probably one of the hardest questions I've seen in an exam paper. It's not a long question, just one that's a bit hard to grasp. So the general equation that it gives, I've just drawn a small Cartesian plane here to explain what I want to in a moment. But so the equation here, y equals x ln of x. If I were to plot this on a graph, see, it asks about the tangent that passes through the point 0e. So effectively that means, because a tangent to a graph is always a straight line no matter what graph you have. If you have an ln graph, so for example, if you have an ln graph, a tangent would always be a straight line, if I can draw a straight line, across a single point. But an important thing to consider is that in any form of graph, whether that be a log graph, whether that be any of these graphs, at this point, this tangent equation is dependent on two things. It's both dependent on the main function that it's based off and the x point that it's based off. So, yeah, so essentially, if we were to find a tangent that crosses through a point, there would be one specific x value. So if we draw just a generalized log graph, let's just pretend this is the ln graph. I'm not putting units in because it's just a general curve. But then let's say a single point of here. So this is the point that it says it passes through, which is 0 and negative e. So this is at x equals 0, obviously, because it's at the on the y-axis, so it's x equals 0. And negative e, so it's negative e below, which is around 2.71, like negative 2.71. So if we plot this point here, the question is essentially asking a tangent that hits this point. So if we, obviously we can't draw infinite, but if we drew across this curve an infinite amount of straight lines that touch at a certain point, if we just keep drawing these, eventually there will be one x point. Take this one for example, this x point here, where it crosses this point that it says, and this will be the tangent line that we're looking for. So I'll just get rid of all these for a second, and we'll just draw this tangent line across, just a straight line that hits a certain point that passes through this. So this is the point that we're essentially looking for, because you're going to need that to find the question. It's just something to consider, because when solving this question, that's a very important thing to consider. It's at a certain point, this x point, which I'll probably just call t. So you have, so in the so that's just that Cartesian plane was kind of just to explain that concept. It's very important to know. So in the curve y equals, I'll decrease my so it's easier. Y equals x ln of x. So this is your main, so I'll go back to here, sorry. So this is your main equation, but you have to remember this is a straight line. This tangent point that's going to pass through this point here is a straight line, which is going to follow the equation y equals mx plus c. Your c being the y-intercept and your m being your gradient. Now, it is initially thought that you can kind of just find the gradient, but you need, actually scratch what I just said, but you should just know that this is not where the gradient should be looked at from, if that makes sense. This should just be a point that it passes through. It's very important. So I don't want to make this video to kind of just give you the answer. I want it to be understandable, if that makes sense. So your equation for the tangent line is going to be based on this. Now, to get the gradient at this point, it is known that using the main equation, you can get the gradient at that specific point if you sub that value in. But you don't really know that value, that's the thing. So you need to find that. So your first step would be to differentiate the main function, which is, of course, y equals x ln of x. So, yeah, there are two ways of deriving this straight line tangent curve. The first way is by finding the derivative to this point and subbing in x, but we don't currently know x. So first I'll do that. So I'll zoom in here a bit. Move this over. A bit awkward. Okay, there we go. So your y dash, you're going to have to use the product rule, so just know u equals your first function x. So u dash is going to be equal to 1. V is going to be equal to ln of x. V dash, according to chain rule, is going to be 1 over x. because when you differentiate ln x, it's kind of just, you put whatever's in here on the bottom of the fraction, and then you multiply it by the differential of in here, but that's just 1, so you're just timesing it by 1. It's 1 over x. So your function, I'll draw this y dash down a bit, so it's not in the way of, so it doesn't cut into here, essentially. So your y dash is going to be uv dash plus vu dash, so it's going to be x multiplied by 1 over x plus v ln of x times 1. This will come up to the top and cancel and equal 1, so this is going to equal 1 plus, and then ln of x times 1. So this is going to be your y dash, but also remember that your rate of change, your y dash, your gradient, this is your gradient value at x point. You have to remember that's very critical, because it will tell you that at this point, at this x point, because if we just ignore this as t and just call it x for the moment, so if we call this the x point, if you put in your x into this equation, you will essentially get the gradient at that point, or the m value for the tangent, which is, yeah, it's calculus. So now that you have that value, because we know that x at this point, x at this point into that equation will give you m, because it's the derivative. Let's just call this y dash m, because it's going to be the gradient of our tangent. So now m equals 1 plus ln, but x at this point, because we're not just using x anymore, because we're using the specific m value for this gradient, because we're trying to find this, the equation for this straight line here. Sorry, I can't draw. So let's just substitute this in as t here, because this is the point we're working with, t. Okay? So m equals 1 plus ln of t. So that's going to be your formula for the straight line. Now, because we don't have a way to determine what t is currently, if you look at the information in the question, it says it passes through the point 0, negative e. So it passes through 0, negative e, which means it's a valid point in the curve equation. Now, knowing that this is a valid point in the curve equation, which means that the tangent hits this point eventually, as shown in this diagram here, at that point, there is another straight line equation gradient. There is another straight line gradient equation of y equals, m equals y2 minus y1 over x2 minus x1. Because you're taking 2 points and then taking the average of the gradient of the rate of change. And this only works usually with straight line equations, because it's, yeah, it wouldn't really work with any other curved equations. Line equations. So, using this, because we know that we have one straight line equation, but we have no way of finding t. We need to find the t value at that point. Remember, this is the t point. This is the x point that we need to find is t, which is here, because this will give you the x. Not necessarily the x, but the m to find the x in this equation. So now, let's let this m, which is y2 minus y1 over x2 minus x1. So we know that these two are completely valid points, right? So let's, how about, because this is an x and this is your y, x by y, that's your coordinate. So now let's call this, because t is what we're trying to find, so let's just call t and the y for t, because t is an x point. Let's call this our x2 and our y2. But let's call these 2 points here x1 and y1, because these are our first point, because this doesn't matter what way you order it, the 1s or the 2s. In terms of, like, you could call these 1 as well, you could call these 2 as well. It doesn't really matter, but you just need to make sure it's constant, because this, so if we have x and y, point 1, this pretty much means that these are the same point. So x and y, these link. So you just need to know that. So if we sub this into the equation, you know that in this equation, the point at the curve, so this y point here, this point here, because the only way we're going to find this curve is by using the actual equation. And the reason for that is that, see the original equation we start off with, y equals x ln of x. And the reason for that is because these points touch at the exact same point. So this straight line curve and this curve, they touch at the exact same point. So because we know the equation for this, y, we can use that to help. So let's take the second point by doing that. So that would mean that if x is equal to t at that point, your equation for that point of tangency, as QCAA call it, would be at t, and then the comma, like at point t, and then you need to sub x into this. So t, ln of t. So that is the point of tangency, which we can find using this equation. So that means we can call this the x2 and the y2 because we've subbed that in. Okay, just ignore this for now because this is the same as this, except we've subbed y in and put x into y, which is t, because we've taken this point and called it t. Now, so let's sub this in. So m is equal to y2, so t ln of t, minus, see this point, y2 minus y1. y1 is negative e. Put this in brackets because it's just the number itself, is that, over, and then x2, which is t, minus x1. x1 is 0. So you just need to remember, because you're finding the average of two completely valid points, and that's how you'll find your gradient. So 0. Yeah, so x1 is 0. So t minus 0. So if we simplify this, you get t ln of t plus e, two negatives equal positive, over t minus 0. And that's going to equal your m. Now that you have two valid points, you have two valid solutions for m, which are these both. So you can make these equal each other. So let's call this equation 1. Let's call this equation 2. You can go substitute. Or not substitute, but let m equals m, because we know that m equals m, so m equals m. Now we can sub both equations into both sides. 1 plus ln of t is equal to t ln of t plus e over t. Now we can put t on this side of the equation, because now we only have one unknown, which is t. We don't have any more unknowns than just one, which means we should be able to find the value, well, hopefully. So let's multiply this side, both sides by t, which will give you, if you expand these brackets, t plus t ln of t equals, these will cancel, so you'll just be left with the normal equation, ln of t plus e. Now t ln of t is present on both sides of the equation, so you can subtract t ln of t from both sides, which will get rid of these. Then you have t equals e. Now we know that t equals e at this point. We can take this, because we know, so now that we have this point, and this point is what t is equal to, this point here on the x. So now that we know that t is equal to e. So now that we know that t is equal to e, sorry. Now that we know that t is equal to e, we can put t back into the equation of our gradient equation. A gradient equation being equation 1, because pretty much the easiest one to substitute e into. So now sub, let's just do a double arrow here, sub t into 1. So now, if we go back to 1, m, because we still don't know the m yet. We got rid of m to find t by making m's equal each other. So now m equals 1 plus ln of e. ln of e is equal to 1. So we can just make this equal 1, which m equals 1 plus 1, which is 2. Now if you go back to our straight line equation, y equals mx plus c. Now we know m is equal to 2. So y is equal to 2x plus c. And now if you, it should be known that to find c, c is going to be your y-intercept in a straight line equation. But you know from the information provided that it crosses at 0e, and this is a y-intercept because x equals 0 at y-intercepts. So that means your c is going to be equal to negative e. And you can prove this because you can substitute these values into the equation, because this is a valid point that the gradient passes through, so you should get a valid answer. So by doing that and not using this y-intercept logic, you can go, I'll just continue below the paper. So the equation was y equals 2x plus c, but it crosses through the point at x equals 0, because it's 0, negative e. So this is your x and your y. So cross through the point x equals 0, y equals negative e. So let's sub this in. Negative e is equal to 2, 0, plus c, because we've just subbed 0 in as x in as 0 from this point, and y in as negative e at this point. So now negative e equals, this disappears, plus c, c equals negative e. So now taking this point and putting it back up to here, y equals 2x minus e. That's the solution, because we found the tangent equation. Thank you.